All right. So thank you so much for waking up so early after the party. Listen to me talk about unit testing. So today we're going to talk about practical unit testing. So that's sort of how I added tests to my own projects without, like feeling like I'm wasting time, without feeling like I'm spending too much time in the details, and making it work for me, making me more confident. So, we'll talk a bit about how to write unit tests, but I'm sure lots of you already know how. So we're going to talk mostly about what kind of unit tests you should aim for and how you should, make them helpful. So unit testing covers, unit testing here means like automated testing, write code to test other code. I'm not going to just keep it to the small scope sort of unit testing that we often refer to. It's going to be broad, just automated testing. And I'm trying not to be too opinionated on stuff like TDD. So if I come off as, opinionated, just forgive me. It's OK. You can do whatever you want. All right. And after last night, I decided that this talk was best for idiots like me. Because, if you think about it, it helps a lot, especially when you're an idiot, to have unit tests. Cool. So we're going to look into why we unit test, right? We're going to step back. We're not going to subscribe to sort of a philosophy that unit testing is the best. We should write as much as we can. We're going to look at why we do this and how we should approach this. So some pros. Unit testing, obviously, helps you identify problems early. And this is super important, and it really scales up when you have more developers, right? You want to know your problems early so you can fix them, and you don't want commits to be piled on top of them. You don't want to try to go back and read your code. As an idiot, it's really hard. So tests help you debug code that's fresh in your mind. Unit tests act as living documentation, and this is especially important for idiots because comments get out of date, documentation go out of date, but tests, they are code. So they compile with your code, they run with your code. If you change your code, you'll have to update your tests, so they're always up to date, and they document how you expect your code to work. All right. Most importantly, they increase confidence when you ship. So when you finally finish your coding, at the end of the day, you're going to do some manual testing. You're going to do as much testing as you can, but you're probably you have a deadline, or you really want to get this thing out the door. It's all about confidence, and unit testing gives you the confidence to upload to the Play Store, make it live. Lastly, testable code is generally better code. We'll look at that later in the talk too. Just by writing tests and thinking about writing tests when you're coding, you can have better code, which is great. Now, there are cons of unit testing, and there's sort of one main one, which is they take time to write and maintain, right? Like if they were free, we would all be writing tests all day long. So, yeah, 4 pros, 1 con. Pretty, right? Pretty good. Making my case here, all right? Thank you for coming to my talk. All right. Thanks. All right. April Fools. All right. That was my terrible April Fools joke. Now that that's out of the way, let's look at some serious stuff. Practical test suites. So with pros and cons, there's only one con, but it's pretty big, right? Our time is limited. We're paid for our time, and especially if you're working on your own, on a side project, your time is even more constrained. Contracting, you're billing your time. Time is important. But there are a lot of pros, too, so we have to try to balance it. And sort of how I approach this is to look at your test overall as a suite. So if you have a test suite that's practical, you don't have, it means that sort of as a whole, it can give you more confidence, right? Each individual test sort of adds to the confidence, and different kinds of tests, which we'll look at later, sort of add to that in their own way. Now, there's 2 axes that I will put sort of unit tests on, and that's good tests and useful tests. And they're sort of orthogonal. You can have a very useful test that's just a terrible test and takes all the time in the world to maintain, but it's super useful, and that's good. And you can have a good test that's not useful. It runs super fast. It's just super well written, well crafted, but it's testing code that is like dead code or never runs. And so sort of you want to avoid that, but I'm here to argue that good, useful tests are useful, easy argument, but that also you can sort of be flexible on this goodness scale of tests sort of to be practical, right? You can't if you're focusing in the top right quadrant, you're going to be spending a lot of time to make your test good, which I'm here to argue might not be the best use of your time. So your suite should be easy to maintain and build upon, and that's easy if you're skewed toward the good side. And overall, we're just using unit testing as a tool. So once you look at it sort of this way, in terms of usefulness, you want to be thinking about how it benefits you, right? You don't want to write tests that are not useful because they won't add to your confidence when you're shipping. And we want to use this tool as developers to make us better developers. Let's take a look at what I mean by useful tests. They test testworthy code. Another crappy, easy to justify statement there. So testworthy code is code that can be sensitive or frail. It breaks often. That makes sense. If it breaks often or easy to break, that doesn't mean it's bad code, right? Often there's stuff out of your control. It's testworthy. Code that is critical. It's really important. If you're writing a spaceship app that's controlling rockets and spaceships, you should probably test some of that code. Code you have less control over. It doesn't have to be sensitive or frail, but if you don't have full control over it, it processes random input from users or internet, probably testworthy. And finally, the point is you know your code best, and that goes with the theme of this whole thing, which is you decide on what's worth testing for your individual app or for your team, whatever builds confidence, right? If you have like superstar programmers, you might not need as many tests, right? But most of us are idiots like me. I need a lot of tests, and it's very helpful. Cool. So useful tests, in my opinion, are most important, again. But good tests are important, too. We want good tests. Good tests should run quickly. They should clearly tell you what's broken, right? When they break, they should tell you, all right, this is broken. Look here, fix it. And since they run quickly, you get to run them a lot, so that helps you catch problems early. And be easy to maintain. So you want to ideally write it once and never touch it again and have it, build value over time, which is great. Cool. So back to this practical test suite. Every test should be useful to you. Again, you or your team. Most tests should be good. I'm not saying bad tests are good. Good tests are good. And again, reiterating, they should make you more confident to ship. So yeah, again, I'm just going to note how subjective I'm being on these terms. Everything is very qualitative, sort of qualitative. I'm not chasing anything like code coverage or sort of absolute test count. It's good to have, those are all good things, and especially, to make your test longer to run. But that's OK, because in next talk, you learn about continuous integration, so you actually don't have to run your tests on your own machine. So, more tests can be better, but that's not my goal here, as sort of working on my own projects, testing my own apps. And again, idiots kind of need more tests, like me. So, I don't have a chair. Let's do the demo. I was going to grab that one. Cool. All right. So in demo 1, we're just going to use the 2016 version of the RWDevCon app. Do not be confused by this app. It has the data and schedule of the 2016 RWDevCon. It was open source. I updated it to Swift 3, so I wasn't the original author of it. But it doesn't have any tests, like a regular app. So we're going to take a look at it. So in the practical unit testing, we're in session 14, in case you need that. In demo 1, open the starter project. Make sure you open up the XC workspace. And you should have our RWDevCon app. I'm just going to run it here to show you. And it's a nice app. Let's do this. All right, you guys can see this. We're just going to explore the app a little bit. It's nicely sort of modularized. There are lots of folders. There's code in the folders, as you expect. And the app is very similar to what you have on your phones today, but with different sessions. So again, don't use this as your schedule. Yeah, so let's take a look at adding tests. We're just going to jump right in. We're going to create this test target, and then add our first test in case you've never done this before. So to get started, wow, OK. I'm going to have to stay in this. Add a new target. You always need to do this. Ooh. All right, and you're going to scroll down and look for iOS unit testing bundle. Add that. And defaults are usually fine, but make sure you have Swift and the targets are what you expect. Press finish. And not much changed, but you get a new test folder down here with a single Swift file. We're going to ignore that file for now because we want to create our own. So what we're going to test here is something that I mentioned, which is something that's out of our control. As this app has a schedule. You're all well aware of how this app works. And that schedule is loaded from data, which is a plist file. So it's kind of a normal pattern of you have some data, you load it into your app. And sometimes you edit the data, sometimes you get the data from somewhere else. It's kind of out of your control. Your code that parses this data is often decoupled with the actual data. And if we look in other app delegate, I'm going to have to get used to this, app delegate, you'll notice that the data is loaded first thing in the app. Because you open up the app, you got to load data. So there's this code up here that loads a plist and then loads data from the dictionary. And this is just one function that loads everything into a core data stack. And this code it defines what kind of data it expects. And your data better match that format because, it has to be parsed. So we're going to test this. We're going to start by creating a new file in here, inside the test folder, if that wasn't clear. And it's going to be a unit test case class, which I'm glad is default here. And press next. We're going to name this one data tests, because we're going to be testing some data to make sure it's there. And it should be added to the test target. Go ahead and create that. So you get this nice file with some examples. We're going to go a little bit slow here in the beginning, just in case lots of people like me a year ago have never seen unit tests before in iOS. You get the setup and teardown function. So it's not too new, right? It's a general class, and it's a subclass of this test case, which means it's a test case. And there's two examples down here. We're just going to delete them because we're going to write our own. What we're going to do is we're going to write a function to test that our app has sessions. And by sessions here, we mean like RWDevCon sessions, right? So we're going to start that with a func, start that with the test word, and that's really important. So this means it's a test case, and you need to, it has to start with a test. And we're going to test that initial data has sessions. So you want to be descriptive with your names. That's part of having a good unit test. You want to know what's going on. OK, we have a test. We can run it. You can run it by clicking this icon here. And it's going to pass. So I'm not going to wait for that. How are we going to test this code? It's in app delegate. It's called from init, like did finish launching with options, which is a good place to call it. But we don't want to spin up the whole app with app delegate just to verify the data, right? We want to isolate this data loading code, which would allow us to test only that piece that we care about. And at the same time, this is to write a good test. We want to control its inputs and outputs. We want to make sure it doesn't do anything we don't expect. And so we sort of have to move this code. We got to move this code out of here so we don't have to create a new app. And we're just going to do that by creating a class function down here. So below that did finish loaded with options, we're going to create a class function. And we're going to load initial data. Since we want to control the output, so ideally we want to control the input and outputs. In this case, we're going to keep it simple. We're going to control the output, which is the core data, where like the output of this function, even though it doesn't return anything, it's storing information into a core data stack, so we can pass that in. Right. And now we can just move all this code from this guard statement up here down to this load data. Make sure you get the last parentheses in here and paste it down here. Cool. Now you're going to get some errors. 2 errors as expected. One is the return statement. I'm just going to remove that true because we don't return anything anymore. And the next one is because it doesn't know about this load data from dictionary function anymore, because it's down here and it's a member function. It's a method, and we're going to change that to a class function as well. So now it knows about it. It's in the class sort of global scope. And we're going to have to pass in the core data stack to this function as well. Cool. Lastly, we're going to call our new method, make sure our app still works. And we're going to pass in the core data stack, and oops, should be lowercase, which is sort of this lazy variable we have up here, which will be instantiated for us. So what we did now is we pulled out this code, right? We did some refactoring, actually. It was pretty easy, and we did it to test this code. But to be honest, all right, we have to add this. We have to pass the core data stack down here as well. My bad. Core data stack. And that should build now, which is great. And yeah, now we have class functions. Class functions are sort of the ideal for unit testing, right? By definition, they can't affect anything in their class. Any properties or other things, but they can, have side effects, which this code does have. It reads from the disk, which if you're going to improve this test further, you might remove. And it also loads to the core data stack, which you could break out as well. And there's all this stuff down here, so it might not be the best test, but it's getting a lot better. So back in data tests, I went back to data tests in case that wasn't clear. You see that our test passed, which is great. That's our first passing test for today. But we're going to actually, make it useful. We're going to start up here and import what we need. We're going to import core data because we're going to use that to verify that we have sessions by querying whatever the result is. And we're going to have a special import here called testable import. And we're going to import RWDevCon. RWDevCon. And this @testable is really cool because it gives you access to the internal methods of sort of this module, which usually you wouldn't have, right? You would only have public access, and that's bad because that would mean whatever code you want to test, you would have to make public. You don't want to do that. Whatever is private or internal should stay that way, and it's much better to test without having to escalate that permission. Cool. So we're also going to define a core data stack for our tests. And it's going to look a lot like what we have in app delegate. But now it's in our tests, and we fully control it now. We have full control over this. And we're going to make it an implicitly implied optional, unwrapped optional, because that's fine, because we're going to create it in setup, and we're going to get rid of it in teardown. And so there's these two special methods here that I'm going to indent properly. Which are called before and after every single one of your test cases down here. And this allows us to set up our core data stack just by creating a new stack. And it lets us tear it down. So this is what allows us to have implicitly implied unwrapped optional up here, because we know in every test that it'll exist because we create it here. Another reason we don't want to just sort of have it be, say, a lazy var or a constant that's created is you want your tests to be isolated from each other. You don't want them operating on the same core data stack. You want to create a new one every time in case you have a test that adds some data or removes some data, and then the next one might fail depending on the order they're run. And you definitely want to avoid that. That would make your tests flaky. Cool. So now to write the actual test, it's actually not that hard. We're going to create a fetch request. We're going to load the initial data first. So since we have access to internal methods, it should come right up. I'm going to pass in our core data stack up here, which we know exists at this point. And then we're going to create a fetch request, which is a NS fetch request, and we want a result. So after we load the data already exists. So we're just going to fetch entity name session. We're just going to fetch sessions. It's a regular request. And to use it, we actually have to use a do try block, right? Because when we're querying core data, that thing might throw. So we are going to have a do block. And we're going to fetch our sessions equals, and we're going to have to try that. We're going to access the context within our stack. And we're going to call fetch. So if we get sessions and it doesn't throw, then now we want to verify our expectations, which is we have sessions. And we do that with XCT assert. And there's a whole family of assert methods provided to you by XCTest. And we're going to use greater than here. So generally, any kind of comparing with nil, not nil, you can do, or you can just have a assert a Boolean. We're going to have greater than, and we just do sessions.count. And we're going to say greater than 0. So that's all you really need, but we do have to catch this exception. And if you fail the query, we're going to say our test failed, because I think that's pretty reasonable. You can just say that it failed down here. And that's our test. Cool. So to run it, you can press this arrow again, or you can see that, go up here and choose this test thing, which is the same as pressing Command U on your keyboard, and that runs all the unit tests in your app. So once we do that, it will attach, and it passes. Yay, that's an actual test. So now, yeah, that's actually just it for this demo. We're just going to look at how that works. So look at that code we just changed, right? So we wrote a test. Now you're a lot more confident when you get data before you ship, right? Sometimes you make last-minute updates. You make last-minute changes to your data parsing. You refactor your data parsing a lot. That's sort of a hot piece of code, right? But now every time you do that, you're just a lot more confident. All right. So before we jump into the next one, do you have any questions?
See, I'm so busy on Twitter promoting your talk, Jack. I'm sorry.
Thank you. Appreciate it.
Hey, so you said that moving along, you might replace the manual loading of the plist.
Yes.
Given that it's not too big and it probably wouldn't take too long, do you think you would do that in practice, or wait until it was a bigger data set you'd have to worry about loading?
Well, what I mean by sort of moving out of the function is just to further sort of limit the amount of responsibilities that function has. So I would still load the plist, right? It's just that I would load it somewhere else and pass it into our load initial data function instead of having that load initial data function know about what plist it's loading, right? Because right now it's hard-coded in there. So that was my point regarding how big the plist is. You should test it anyways, right? Even if it's small or big, because unit tests are way faster. And even if you had a huge plist with continuous integration, it'll always be worth testing.
Okay, so you were referring to refactoring that code as opposed to removing the actual load from disk from the unit
Yes,
test.
I was referring to removing it from that particular function, moving it somewhere else. That way our test sort of is even smaller in scope, which is what you want.
Okay, thanks very much.
Cool. Thanks. Sorry.
Do we have another question?
Right, so the add testable...
Sorry, the question was, what did the add testable do?
Right, so the add testable gives you access to internal methods of that module. So if you have two modules, you only can access the public ones of the other modules, right? So that would be a pain in unit testing because you would have to make everything public. This gives you internal access.
Just wondering, what about the private methods then?
Yeah, so you can't access private methods. That's kind of annoying. You would have to promote them to internal to test them. I usually have my private methods be underscored. So even though I promote them to internal for testing, I keep them underscored as sort of an extra information that I meant for it to be private, something like that. Yeah.
There we go.
Can you show a quick example, like if you change the core data, the test fails? Can you show that?
What do you mean?
Like, can you show the test will fail if the values that we are expecting are not there?
Oh, yeah. I mean, so if you mess with the plist, is what you're saying. If we remove our sessions, that might. Oh, that's smart. All right. Super smart. Sessions 2. So if we do that, and I pressed Command U to run our tests. It's a good question. And did I not save it? Did I change like a single session? Let's look into this. OK, during the lab, I'll come back. I'll come down, debug it with you. Don't worry, this will fail without the proper data. Another thing is, right? No, this should fail. Don't worry, we'll figure that out. We can debug this. We can debug our test. Don't worry. All right. Or after in the lab, I'm sure we can make it fail.
Hey, Jack, we have someone debugging your code for you.
Oh, cool. Sure.
You have it in core data, so you're just testing if your fetch returns the amount more than 0. So if you run it once, it saves it in core data
right.
the repeated times.
That's smart. That's a part I didn't work into this talk because I didn't test it once I removed it. So ideally with core data, because it saves on the disk, core data has option for a memory store, right? And that's what you want to ideally do when you're testing core data. So that's sort of a core data specific thing. Or whenever you write to disk, core data by default writes to a SQL sort of database, SQLite. Yeah, that was actually removed from the talk. So in the core data stack, let's just go over how we would solve this, which is when you initialize the core data stack, it will create a default core data sort of context, which creates a SQLite file. You could pass in an option to make that a memory store. So you would want to expose that option out of your core data stack, right? Maybe an initializer, tell it what kind of core data stack you want, a memory one or a disk one. And in app-delegate.swift, you would create a regular one, right? You want it to be stored on disk. But in your unit test, then you would create a memory one. And so whenever you set it to nil and it gets deallocated, all your data is gone. So thank you so much for reminding me. Cool. Thanks so much. All good? Should we keep going?
Yeah, are you done the first section of the demo? Or are you still working through it?
No, we're done with the demo one.
OK, we have time for a short break if you'd like. So.
Yeah.
OK, all right, we'll take a short 5 to 8 minute break, and then we'll reconvene for the second half. Thank you.
Cool. All right, so we're back. So this second part, so we got a nice intro to how to unit test in case you guys have never done it before. The code is a little bit nicer, more modularized. And that was sort of an example of testing existing code. So code that was already there, and by testing it, we had to refactor it a little bit. But that's sort of not the most important sort of kind of workflow, because existing code should already be tested. But even if it's not, it's code that's done. Like some of that code is done, has been working, and it's not the best use of your time to go back and test all of your existing code. That was like sort of a special case because the data changes and updates all the time. Like it's hot piece of code, so it's probably worth testing. But I wouldn't, advise you to go home and write tests for like a week and cover your code. Most more important part is when you're developing and adding new features, refactoring, or debugging, you keep thinking about adding unit tests, and you keep adding unit tests. So yeah, so we're going to look in this part of the talk at how we should think about that and write tests as you're developing sort of day-to-day. First, we're going to talk about refactoring. So this is sort of your golden opportunity, right? You got to write tests before you refactor. Like that test we had before, it would be helpful to have when you're refactoring the low data code, which might be because it was a one big function. And it lets you just refactor quickly, because when you're refactoring, by definition, you know the inputs and outputs, you don't want them to change. You can write a test for existing code, and hopefully existing code already works. And while you're refactoring, whenever you get to a certain point where your code works again, you can run the test and verify that everything's going well. But again, like I said before, lots of that's existing code, and it's not the best use of your time to go sort of cover it fully with good tests. Here is where you can trade off signal versus coverage. So you can write certain tests, and we'll talk about later, like UI tests, that give you insane coverage, but give you terrible signal. They tell you something's wrong, but they don't tell you what, right? That kind of test is not good, it's terrible, but it's very useful, especially when you refactor it. It gives you the coverage you need to be confident in your refactoring. So we're going to take a side tour just to quickly talk about UI tests, because it's sort of a topic where either you're like, oh, that's terrible, or oh man, I'm forced to do this at work and I hate it. But yes, it's still terrible. Generally, it is pretty bad, and people who write it, there's lots of nuances, and it's slow because it's a UI test. And that's its biggest downfall, right? You want tests to be fast, and UI tests in Xcode take like 15 to 20 seconds per test, which is good. They're low signal. Since you're testing something on the UI, generally, unless it's something very specific, you don't know exactly what caused that UI to break, right? Like a button's missing. Oh, great, right? What happened to something? Something big is probably wrong. But they give you insanely high coverage. Just by testing bits on the UI, it's exercising so much code, right? So much code is run to show a single button that just by testing the button's existence, you've saved yourself, time to test all that code. And the last point, which is what pushes us over to terrible to, okay, maybe we'll try to use it, is Xcode has great support for UI tests. And sort of, maybe if you start writing a lot of them and go really deep into it, then it's not that easy to write. But at least in the beginning, and if you're looking for coverage, it's very easy to write Xcode. And we're going to do a little bit of that in the next step. All right, so after you refactor, or while you're trying to refactor, you'll have bugs, and you're going to fix them. This is another perfect chance to write really good tests, because when you're debugging, you're finding a problem, you isolate the problem, and you should write a test for it that fails. So that really helps you understand the problem, because now you're exercising the exact code path, you're using the exact sort of input values that causes this code to fail, and you can have a lot of confidence when fixing it, and you can use your test to verify your fix. It's perfect. It doesn't, in my opinion, this saves time, it doesn't waste time. You're already debugging, and you want to make sure your fix is good, you want to come back to it. And once you have the test in your system, and say, it's usually a really good, quick test, like a really fast test that one specific thing that broke, you keep it in your suite. Now it's a regression test. Now it runs every time you're in your test suite, and you can be confident that it never happens again. So, good time for good tests. And notice that, not very useful test. Those tests might not be very useful because, again, you fix the code, and you might, never touch that code again. But they're still good, and so they're worth keeping around. Lastly, and most excitingly, is when you finally get a chance to develop a new feature. And this is your chance to write good and useful tests, right? So notice how all cases of development, you have a chance to write tests. So this is because you should keep unit testing in mind while developing, and that allows your code to already be testable, and we don't have to go back like in the previous demo and refactor it, right? That's how you want your code to start off with. You want your code to be good and testable from the beginning, and this is where, if you're shipping an API, you really want your test to document it. If you're writing code where someone else calls, you're an idiot, they're an idiot. You don't want to give them comments, you don't want to be handholding them. You want to have tests and have specific cases which are sort of you expressing how this code is meant to be called. And when I go back and look at my old code, if I have tests, I'm really happy because now I know exactly what I meant sort of this code to do by the end of testing. And here's where I'm trying not to be opinionated, and some tests can be written before the code. I'm not saying you should do TDD, I'm not saying you shouldn't, but you should consider it. And a special case here is if you use playgrounds, you're kind of already doing this. So when playgrounds was introduced, we sometimes when we're playing with algorithms, we're playing with sort of a nifty sort of piece of code, we pull it out, we put it into a playground, it gives us really quick sort of ability to iterate on the code. And what you're doing there is you're taking, say, a function in your code that you're trying to improve, you're putting it in a playground, and you're sort of running it against lots of inputs and outputs, right? You're you have a bunch of inputs and outputs there, and you call your function, and then you improve your code, and you look at the nice playground output, and you verify that it works. You're actually writing a unit test. You're actually writing many good unit tests if you do that. And so, if you do this, and you finish, that you copy your code back in, think about copying all your examples into a unit test. Now they'll run every time, and now you'll, like, that's immediately free documentation and a great, and in my opinion, very useful unit test. All right, that's all I have to say, because, now that covers all the developing cases. And we're going to jump into the next demo, where we'll start off by writing a UI test. Kind of like the first demo, we're just going to go through the basic way to do that, to show you how easy it is in Grid. And then we're going to develop a small feature and test it, but sort of develop it while thinking of testing. All right. So we're going to be back in this project. I'm just going to close it and use the starter of demo 2, just in case I misname things and keeps everyone on the same page. So I recommend you also open up the demo 2 starter project. It should be mostly almost exactly the same as what we had before. So we're going to start off by adding a UI test. Again, it's almost the same process. We're going to add a new target again. Target up here, and this time we're going to choose a UI testing bundle. Next. Defaults are generally okay. And you get another filter. Here. Whoa. Okay, they're there, good. Excuse messing with me. Too early in the morning for it, need some coffee. So, with your UI tests, the first thing to know, we're going to actually just look at the sample here. We're going to try to make this quick. Is also a XC test case. It is also an XC test sort of test. There's nothing really special about it in Xcode. So Apple made this really convenient. If you know about unit tests, you pretty much know how to write an UI test. There's a few differences, and it's mostly well explained in comments. But if you look down, there's an example, setup, teardown. It all looks the same, which is great. Now, what we're going to do here is we're going to test the app. I'm going to run it again. And sort of say we're going to refactor that table view that sort of displays the session. And we're scared because if we break, that's such an important part of our app. So we're going to write it, and we want to spend too much time testing each individual part. So we're going to write a UI test that verifies that you can go to this page, go to this view, and that sort of these major pieces of information exist. And we'll see how easy that is with UI tests. We'll do that right now. We're going to start with another test. So, fine. Test session details. Keep it a little bit broad here. And instead of writing any code, we're going to use this magical record button that is missing from my Xcode. What's wrong with my Xcode? Okay, it's version. This has not happened before. Let me try adding this target in. Or let me double check that this target exists. Which it does. It's offline, that's fine. Technical difficulties. UI test, I don't see anything wrong. I'm going to delete this and do it again. Or just delete target. Add a new target, UI testing, UI tests. Yay! All right, super. Thanks, good. All right, so I'm just going to take a shortcut, test session details. Details. All right. And so if Xcode is happy today, there should be this record button down here, this red dot. That's what I was looking for in case you're wondering. And this lets you record a UI test. Now we're going to do that. So what we want to do again is verify that pieces of information we want exist in the app. So this is going to be magic. If this is the first time you're doing it, we're going to take it slow. We're going to press that button, wait for it. And that should bring up your simulator, and run the app. So don't click anything in the app yet. We're going to carefully click on this beginning Swift session. And it's going to lag, and code is going to appear. Don't be worried. It's expected. And then we're going to, so we want to verify sort of that these sort of labels exist, because that's the information that we know that's always going to be displayed in this view controller. You can see this. And click on each of these labels, like track, wait for code to appear, when, where. I'm going to skip my schedule just so we don't have too many things to change later, and presenting. So now you put your code in the back, don't be worried. We're going to hit this record button again to stop. So we're just going to look at this for a sec. It's kind of some weird stuff going on. Your app runs, and this is really not a lot of code, right? Each thing we did is only one line of code. It's really impressive. And sort of just querying for this text that you tapped on and calling tap on it. So very simple. But we don't want to tap on these labels down here, right? We want to verify their existence. And so, sort of similar to what we did before, that's our expectations, that's what we expect, and we're going to verify it using XCT assert. But first we're going to change this to the tab, we remove the tab and change it to exists, which is a nice thing to have here. And so we're going to wrap this in XCT assert true. And we're just going to let go of that. And, right? So now instead of tapping on it, we're verifying that it exists. So we're going to do this for all of these. That's why I didn't want to tap on too many earlier. And replace all these taps with exists and close off the parentheses. Cool. So I want to make sure everyone's caught up at this point, because UI testing, you might have to do it twice if you've never done it before. If you're ready to move on, please raise your hand. All right, I guess that's good enough. We're going to run it. So when you run it, you'll notice all the pairs of UI testing, which is how slow it is. I'm going to bring up the console a bit to make sure it's doing something. And so it has to install the app. It has to launch the app, which it's doing right now. It has to wait for it to load, and then it's going to press on the button. It's going to wait for the animations, and do our tests. So that was really awesome. I didn't do anything. That was all sort of UI testing framework. But that took 12 seconds just for the sort of most basic test. Oops, I pressed it. I was trying to press Command Shift Y. Hit U again. All right. So that just passed, which is really cool. So this, less than 10 lines of code now verifies that you can go into a session and that all these labels you expect exist. And in my opinion, that's like 80% of the way there in terms of confidence for me if I'm refactoring that view controller, to make sure that the data is there. And now every time I do something, I run this test and be very happy if it passes. All right, so before we move away from UI tests, this is all we're going to show UI tests. There's a lot more to it, and there's a lot of resources online. I'm going to edit this. We're going to edit the scheme of development because of how slow they are. I generally like to not run them when I hit Command U. So how you do that is you go to this test sort of target, I guess, and down here we'll have all your sort of your regular unit tests and also UI tests, which are more integration or end-to-end tests. And I'm going to check this test check mark. That way, when I press Command U, this doesn't run, which is great. So I can still have my speed iterations with my regular unit tests, and whenever I want to run my UI tests, I do some manually. So that's sort of just a sidetrack to let you know you can do that, so you don't have to be waiting for UI tests all the time. All right, switching gears. We're going to now develop a feature. Now we have a feature request for this app. And Ray, even though he's in the next room, he sent me an email saying, all right, we're going to launch Big in China. We're going to give all the speakers Chinese names, and we're going to, localize the app to Chinese. And, that's pretty easy. You do localization, blah, blah. But there's a problem, which is we have our presenter name here, and if we look in the core data folder, in person, the way that sort of full name is formatted is like this. first name and last name. That's not very good, right? Because that's not how you format Chinese names. You generally want last name, no space, first name. So this is an example, this is sort of a contrived example, right? Where the feature is very specific, we know exactly what we expect, so we're going to take the chance to write our test beforehand. We're going back to data test. This might not be the best location for it. We're going to add it here. It's sort of testing data. It's testing the person class, and we're going to start on this test. So we're going to first test our current functionality, that it's good. We're going to call it test person rates correct full name. And the reason we're in data test is because we have our core data stack. It's going to be a very easy test. We're going to create a person. And there's this nice class method, like initializer, factory method kind of thing, on person. And you want to make sure you choose the one that says or new, because we're going to be creating a new one here. Person by identifier or new. We're going to pass an identifier. It doesn't matter what it is. You can type your own name, Jack. And the context is the context of the core data stack, which again is convenient because we always have that handy here in these tests. Now we're going to set his name, his last name. Feel free to use any name you want. And we're going to go straight to the asserting. And there's one for equals, and equals here does nice object sort of quality for you. And, oh yeah, sure. Let's do that. Okay, cool. So, I'll go a bit slower here. So we're going to make it equal. So we're going to access the full name. And we're going to make that equal to blue. So that's our current existing functionality. And hopefully it passes. Work. And so that should pass. And now we want to add a new functionality. We want to add our chain example, which is we're just going to copy this little test, paste it, change the name a little bit. And now this part is going to be tricky for you guys possibly, so you can copy from the PDF or use whatever you want. My Chinese first name is Tong, and the last name is still Wu. And I expect my name to be formatted like this, which is, if you can tell, the last name followed by the first name. And obviously that's not going to work. And we want to make this test pass. Before we actually go write code, there's actually a few problems here, right? Like this will never work, because there's these two tests, and one expects the English format and one expects the Chinese format, yet we're not changing the locale or anything, and I'm pretty sure you might be able to, but it's really contrived to change the locale of unit test. That's okay, because that's one of the things we want to isolate our tests from. We want our tests to not worry about locale, right? We want our tests to not be able to test that, and so when we're developing this feature, we want it to be testable and let our tests have control over what language we want the name to be formatted for. So we're going to do that. So this failed, right? This is not equal to that, which is right. So I'm going to command click on this full name method to go into the implementation. And we have here that the implementation here, we're going to create a brand new function below it. Oops, still in Chinese, but we're going to create a new function called full name, but pass in the language we want for language identifier, which is the typical two-letter string. It's good. And here we're just going to make it a question mark, so I'm going to return a string. And I probably did something dumb. It needs to be a func, right? This is a func and not a variable anymore. Cool, thank you. So what this is going to do, right, it's just going to switch on the string. Let's just sort of unwrap our identifier. We language, and then we're going to compare it with Chinese, to that, ZH, and if it is, we're going to return, last, first. And we're just going to have the default case of no language or anything else, still returning whatever we had before. And now we're going to make, so because I don't want to change all the code in the app, we're going to make this call towards call our new function. And we're going to make that passing the for the current locale. Current dot language code. Cool, great. So that's our feature. It's a very simple feature. I'm sure you all would have implemented it way quicker than we did here. But by writing a test first and by thinking about it, I would say it's a lot nicer. Instead of just having this if statement up here, we have now isolated the language from the sort of almost algorithm, but really just giant if statement, in case we had to add more languages down here. And this function is very testable. In this function, we can pass off to someone else even and ask them to add way more languages, and we'll be able to test that a lot easier than if it was up here. Cool, so we're just going to go fix up our tests now inside UI tests. Now, not UI tests, data tests. Okay. And we're going to pass in the string. Yep, and that should work, probably the indexing. The other thing is we also want to change one up here, because even though this will likely pass, because it's likely that it's not Chinese by default, we still have less control over this, and we don't want it to be at all flaky. If for some reason the locale changed, so we don't want to have to know the specifics of how locales work with unit tests. And I don't know the specifics. I don't know what it's default to. I don't know if you do CI, if it's running on some other machine, or like what the locale of that unit test will be running with. It might be nil, it might be something random, it might be a locale of Mac. I don't care about that. So you're going to pass in English here. And that's perfectly fine because, this makes this test a lot better. Now it's isolated from that. Is there an actual error here? Hopefully not. We're going to command U on these tests. And hopefully, they should go past. Cool. So, yeah, that's all the code we're going to write for this demo. As you can see, this way of doing things is just a tiny bit different. So we wrote the test first. It was a very small feature, to be fair. It really changed the way, in my opinion, how I wrote this function up here. Usually I wouldn't write it like this. And instead of writing this first and testing it later and coming back and changing it, we had that on the first try. And that is really awesome. So that's the demo. I'd like, I'm not sure if I should take questions, but the lab sort of talks about more ways to write better tests. It talks about mocking. I got a lot of questions about, say, testing networking code or, camera or other stuff that sort of doesn't lend to good code, sort of good tests. And there's lots of tricks and things once you get more into unit testing, once you want to test more things that require you to use more advanced techniques. And Swift is really good for that, so I hope you check out the lab. It talks about mocking sort of from first principles and how to do that without using one of those frameworks. Of course, I'm not against any of the frameworks. I just think that it's good to start from scratch and know what's going on in those frameworks. Cool, so...
Yeah, we have time for any questions if there are any crowd.
Yeah, so if there's any questions, answer them now. I'll also be walking around, flagging you down. I'm a partner, Gemma. You might also be, will be there. So yeah, any questions right now?
Was that about any type of code coverage? Or Does Apple provide any code coverage numbers for you if you choose to exercise that?
Yep, it does. I'm not going to show it here, mostly because I'm not too familiar with it. They definitely do. In the next talk, in continuous integration, you'll also see code coverage covered. And yeah, so yes.
So I was wondering, which kind of frameworks do you recommend to help create unit tests?
So that's the great question. My goal here is not to recommend any frameworks. So I feel like you can write most of your tests without frameworks, and they add, they cloud your understanding of sort of the core unit testing, and it's very easy to abuse mocking to write bad and not very useful tests. But I'll come by later. I just, don't want to give too many, big recommendations on that line.
Hi, I have a question. With the UI tests, is it possible to speed up the frame, the UIs?
As in like animations?
Yeah.
So that's not out of the box. At Facebook we have hack code that makes animations super fast. So no, it's possible, but not easy.
Okay, if we have no more questions, you can launch right into the lab, Joe.
Yeah, so yeah, nothing more to say. Go do the lab. I'll be around if you find me down for any questions. Thank you. All right, that's our time for the lab. Hope you enjoyed it. It was very text heavy, but trying to get a lot of theory across. So yeah, thanks. What did we learn? So in the first part, we learned how to identify test-worthy code and write a basic unit test. In the second part, we wrote a UI test, which is really cool. We didn't write much, actually. We just pressed a few buttons. And we looked at how to write tests as you're developing. And then in the lab, we learned about mocks, how to use those to improve your tests and write more kind of tests. How to refactor your code to be more testable, which is sort of a theme of this whole talk. And how to, craft simple test cases, which is really important to keep your tests understandable and quick. So, where to go from here? There's some nice tutorials on the site that go more in depth about how to write unit tests. So if you're still, wondering about how you should test networking code or, other stuff on those lines, tutorials for that. Next talk, continuous integration, takes all your tests and makes them way better for free. Not necessarily for free, but sometimes for free. Because you don't have to run them on your computer anymore. You don't have to wait for them to run. They'll tell you when something's wrong, and even when your teammate breaks a test, you'll know as well, which is really good. And lastly, add me on Twitter. Thank you so much. Let's go test all the things.